Greetings, my name is Ahmed Remaida and I am a PhD student affiliated with the Laboratory of Engineering Sciences at the National School of Applied Sciences Ibn Tufayl University, Kenitra in Morocco. Alongside my co-authors, we will present this work entitled A Novel Mobile Application for Personality Assessment based on the 5-factor model and graphology. Before to start the presentation, we sincerely thank the editors and the reviewers of the Indonesian Journal of Electrical Engineering and Computer Sciences for their valuable comments, feedbacks, and the opportunity to share our research in this esteemed journal. Psychology has long studied human personality through models like Catel's 16 personality factor, the Big Five, and the MBTI. Though these rely on self-reported data, which can be inaccurate. Handwriting analysis, on the other hand, also known as graphology, offers an alternative by linking handwriting to personality traits, with applications in medical, educational, and employment context. Recent machine learning advancements have improved handwriting-based personality prediction, but still face challenges in feature extraction and practical applications. To address this problem, we propose a mobile application that links handwriting features to personality traits, providing professionals like graphologists with a reliable assessment tool. As stated in the introduction, the main goal of this work is to develop a mobile application capable of predicting the Big Five personality traits based on handwriting samples. To achieve this goal, we started by collecting both Big Five inventory data and handwriting samples from 100 engineering students with their consent. Subsequently, personality scores were calculated and handwriting features were extracted using feature extraction techniques, which were then stored in the final dataset. The next phase involved analyzing the existing correlation between personality traits and handwriting features. In addition, machine learning models were trained and tested to assess the predictability of personality traits based on handwriting. Finally, a mobile application was developed that utilizes both the extraction techniques and the trained models to predict personality scores from handwriting samples. The experimental setup for implementing and development consisted of a Lenovo laptop with 8-core 2.3 GHz Intel 10th generation CPU and 16 GB of RAM with an 8 GB Intel GPU and 500 GB of storage, with a Python 3.7 and libraries like OpenCV, Flask, and Scientific-Kit-Learn. Additionally, we chose Android Studio integrated development environment for the mobile application development with XML for user interfaces and Java for handling event control. The first phase of this study involved data collection, where participants completed a personality questionnaire and provided a handwriting sample. For personality scoring, the study used the 5-factor model, specifically the French version with the 10 items, Big Five inventory for faster assessment. As for handwriting samples, participants rewrote the London letter model for handwriting collection, which includes upper and lower cases, letters, numerals, and features suitable for handwriting analysis. The next phase after data collection consisted of processing and storing both personality traits scores and handwriting extracted features values. For personality trait scores, we used the formula presented in the original paper presenting the Big Five 10 inventory. The table 2 describes the score calculation for each one of the 5 personality dimensions. As for extraction of the handwriting features, it is essential for accurate predictive modeling. We implemented robust feature extraction method focusing on pre-processing and optimizing handwriting samples, starting with grayscaling, Otsu thresholding, and median filters denoising. As presented in the figure 2 below, we enhanced handwriting image quality for further analysis. Then we applied morphological transformation like dilating, contouring, and rotating lines. Bounding boxes were drawn to calculate each line's angle, and a fine transformation straightened the lines. The overall baseline was averaged from all lines as shown in figure 3. After straightening handwriting samples, we used horizontal projection algorithm to sum the white pixels horizontally in order to identify line start and the middle baseline indices. The top margin was calculated from the first two indices and line spacing from the distance between middle baselines. The illustrated figure 4 shows this process. As for word spacing, we applied dilatation on segmented lines and used vertical projection to calculate once again white pixel sums and find space start and end indices. Figure 5 shows the vertical projection and the segmented words based on these indices. Letter size was also calculated by applying dilatation and vertical projection on segmented lines to trace the start and the end of letter indices. The difference between these indices gave the average letter size for each line, and the overall letter size was the average of all lines. Figure 6 illustrates this process. The final dataset comprised standardized handwriting features and transformed personality trait scores. After storing both personality trait scores and handwriting features in the final dataset, comes the correlation analysis with purpose of exploring relationships between these variables and evaluating machine learning models for predicting personality traits from handwriting. As the final step, a mobile application is developed to automate handwriting feature extraction and Big 5 personality prediction as a functional tool for personality handwriting assessment. The figure 7 shows the app's architecture with an API handling requests and predictive models via ngrok tunneling. In this section of result and discussion, we start by presenting a general description of collected data where among the 100 participants, 52% were female and 47% were male, indicating balanced gender representation. Also, females scored higher scores in openness and neuroticism, while males slightly outscored females in agreeableness. Both genders had equal scores in consciousness and extraversion, consistent with prior research on gender differences in personality traits. More detailed findings are shown in Table 3 below. For the correlation analysis result, the baseline showed a significant negative correlation with agreeableness, indicating that higher baseline values were associated with lower agreeableness. Top margin had a positive correlation with consciousness and a negative one with extraversion. Additionally, neuroticism negatively correlated with letter size. These findings are consistent with previous studies on handwriting and personality traits. The Table 4 presents the detailed correlation coefficient and their significance. As for machine learning evaluation, models were trained on 80% of the dataset and tested on the remaining 20%. Two scenarios were tested for each classifier, a 5-class and a binary class predictions. Multiple trials and errors were conducted for performance evaluation. In the binary class scenario, the SVM, the RF, random forest, and the MLP performed well in predicting openness with metrics above 19%. Similarly, for consciousness, all classifiers showed excellent training and testing results. While extraversion saw MLP outperform the others, for agreeableness, RF and MLP led the scores, and for neuroticism, SVM excelled with strong testing metrics. Overall, random forest and multi-layer perceptron consistently outperformed other models, making them suitable for binary classification or binary class personality classification. In the multiple class scenario, random forest and the multi-layer perceptron achieved a testing accuracy and recall of 75% for predicting openness traits, while SVM and gradient boosting reached 67% and 73% for consciousness. Random forest and MLP also excelled in predicting extraversion with scores above 60%. For agreeableness, random forest led with a testing accuracy of 75% and strong precision and recall. Gradient boosting performed best for neuroticism, but random forest was more precise. Overall, random forest and multi-layer perceptron consistently emerged as top performers, making them strong choices for multi-class personality classification. For a more nuanced evaluation of our best models' performances, we present in Table 5 below a comparison with findings in previous relevant studies that explored the binary classification of personality traits employing the 5-factor model. As for the multi-class case scenario, we best the best models that will be implemented in the mobile application, making them reliable options for personality trait prediction within the mobile application architecture. The final result of this work represents the mobile application that uses previous handwriting feature extraction techniques and top machine learning models selection for fast, accurate personality prediction. Here in figure 10, we demonstrate the app's user interfaces, as A represents the start interface prompts for a handwriting sample. B, the captured photo is displayed for cropping. The cropped image allows user to retake the photo. D, loading screen appears while waiting the server response. And E, the final screen shows the predicted Big 5 personality trait scores. Through this mobile application, we have introduced an innovative solution for real-time personality prediction that automates handwriting feature extraction and predicts Big 5 personality traits with machine learning models, achieving promising performances as contrasts to existing applications. In conclusion, this study highlighted the potential of automating handwriting analysis for the 5-model personality trait prediction, presenting a novel way for future advancement in the field of computerized graphology. And through this work, we have proposed robust handwriting features extraction technique. We have confirmed existing correlation between specific handwriting features and traits like agreeableness and consciousness. We have also trained and tested machine learning models and developed a novel mobile application for practical personality assessment. Despite this achievement, this work remained limited by the size of the constructed dataset that contained only 100 samples, the limited range of handwriting features with only 5 features, and the focus on one personality trait models like the Big 5 models or personality traits models.